Hello everyone, today I'm going to introduce how do I build the cyclic prediction model. So first, I have performed some data exploration. I have read through each columns and I can see there are bool, there are some numeric, and there are also some categorical data. So when I find out the label is two categories, so I just did a imbalance check, and after that I found out the false values is way larger than the true values. So maybe I need to do some pre-processing to overcome the imbalance. And also I have plotted a correlation matrix and I find that there's no such there's no a lot of features that are correlated to each other. And I find a threshold which is 0.5 and minus 0.6. And during this in these two thresholds, so these 6 features are very correlated to each other, but this might also because the many categorical, the bool variables are just false and true, and false takes a lot of weight. And so they might be not truly correlated. And then I also navigated through the NA values, and I find there's only one column contain NA values, which is the annotation Adam rec. So after that, I performed some like simple data processing, like just use some random sampling strategies to use smoke and random on the sample. And after that, the Y has become 90, so Y has become more balanced. And then I just use these data to try some models. First, I tried the logistic regression. It doesn't perform as good as the other models, and also the XGBoost. XGBoost performed very well, but still, random forest is the one which performs the best. And also the neural network, it performs very slow and it runs very slow, and performance is not as good as the other models, and the light GBM, which also doesn't perform good. And the voting classifier, which takes a very long time to load, and it doesn't perform as good as the random forest. So that's why I'm choosing the random forest as my major model. And also after that, I'm gonna pre-process my data. So first of all, I just look through all the data and find out some of the numerical data are in a very large range and they are not normally distributed. And I check the non-values, which is the annotation Adam rec. When I read through the data dictionary, I find that the annotation rec and the annotation sequence are the same description. So I wonder what's the difference between them. I find out, like, except the non-values, all the other values are just the same. So that's why I decided to drop the annotation Adam rec. This column, this is too long. Okay, so I decided to drop it, and after that, all the non-values are canceled, and then I check if there are duplicates in this data set. And fortunately, there's no. And then I'm going to deal with the categorical data. So I encoded the categorical data with a label encoder rather than one hot encoding, because there are too many categories for the categorical data. So if I use one hot encoding, the features will be too much. And then I need to scale the numerical data, because most of the numerical data are not in normal distribution. So I just use min max scaler. And after that, I don't want to scale my categorical features, so I just revert them back. And then I'll check outliers. However, the outliers are a lot for these bool features, because the bool features has a very large weight on false and a very small weight on true. So I'm not gonna deal with that. And then I'm gonna deal with the imbalanced data. So I choose to use mode combined with a random undersample, and I will feed the data using the random forest and using different sampling strategies to see which one performs the best. I've tried these combinations, and after that, I find that like the 0.6, 0.9 performs good, and 0.8, 0.9 performs the best. However, I have to consider how large the data set is, because it might run very slowly. So that's why I chose 0.5 5 and 0.8 at the end. So it can not only avoid the overfeeding, but also reduce the time it runs. Also, like its performance is very good. And then I outputted my preprocessed data to CxC so it's convenient for like the model tuning. And here is my next step. I'm gonna tune the model. So I've tried some combinations of the model in the random forest and using the ROC AUC and PR AUC and F1 as my criteria and as my metrics. I've tried the class weights, which is balanced or assigned 1 for the false data, or then 1.2 for the true data because it's imbalanced. And I have tried the bootstrapping is false, and this performs good. And the max features because we want to, this performs even better. However, for the N estimators and max, and for the N estimators, it doesn't perform as good, so I'm not going to change it. And for the mean sample split, if it equals to 3, it has the best test AUC PR. And after when I test some other arguments, they're not performing as good at it. So I'm just decided to take the model that's just a class weight has been modified a little bit, and bootstrap is false, and mean sample split is 3, and the max features log 2. And after that, I did a feature importance analysis using just the feature importance variable parameters of this model. And here is what I got. The most important feature is the feed DS is P11, and the second most is the PLDTT. And then I saved the model using a Pico, and also I predicted the test data set. And at the last, I hosted using the gradient space of my model. And here's some examples. So I input this one and I submit, and I return, they were classified as false and false. And here is my Git repository. I have all of this in my README files. So that's all. Thank you guys.